All right, guys. So in this video, we're going to talk about, I'm going to give you guys an introduction to negative exponents, and hopefully we're going to dig into sort of like what they mean, how they come about, how do we find them, how do we write them, a little bit of that. All right, so this right here is just a general rule example of what a negative exponent looks like. So it's always going to be written the same as an exponent, where it's going to be, it's still a superscript, meaning it's, up on the right of the term that it's taking the exponent of, but but in this case you'll always have a negative sign right in front of the exponent, not to be confused with if you have something like this. My exponent is still positive, so in order for it to be an exponent, it would need to look a negative exponent would need to look something like that right there. Let me try to rewrite that like x to the minus 2. Okay, so what we know and what we're told is any non-zero number to the negative n power, and n is just whatever number they decide to make that exponent, is the multiplicative inverse of its nth power. Now that is a mouthful, and this whole multiplicative inverse thing, I want to kind of dig into what that is, so that we have some sort of sense of what we're talking about and when we figure this out. So what a multiplicative inverse is it's anything. So if I take a number, if I take 3, if I want to find the multiplicative inverse, it's something that I multiply. That's where the multiplicative comes from. That I would multiply the inverse of this number, and the answer will give me 1. So what can I multiply by 3 to get 1? Well, you know that, like, for example, if I decided to multiply, 2, that's not going to give me 1. So that's not going to work. If I, even if I multiply 1, that gives me 3. If I continue to go bigger, if I go 6, that gives me, the numbers get larger and larger. So obviously it's going to have to be some kind of a fraction. Well, what we know about multiplication is when you're multiplying something that's a fraction, right? You're putting this number over 1, and then you're multiplying. So if I multiply 3 times 1, that's going to give me 3. Well, what number would I have to have in the bottom here in order to get this to equal 1? Well, it would have to be the same. It would have to be 3 divided by 3. So 1 times what gives me 3? Well, 1 times 3. So what a multiplicative inverse is basically is I just kind of went around a long way to basically show you guys that it is the reciprocal. It's the reciprocal. It's when you take the number and you flip it. So if you have a number that's already a fraction and you want to find the multiplicative inverse, you just take this baby and you flip it upside down, and so it becomes 4 over 1, and that would be your multiplicative inverse. If you have a whole number, so if you've got 7 and you want to find the multiplicative inverse of that, you treat it as 7 over 1, you flip it, and you get 1/7. So that's what a multiplicative inverse is. It's the reciprocal. So now if we look at that definition again, any non-zero number to the negative n power is the multiplicative inverse of its nth power. So let's look at that, all right? So let's take an example of this. Supposing I have, and I'm sort of looking at this, all right? So supposing I take 5 to the negative 2 power, okay? So if I'm going to work with this, all right, it says any non-zero number to the negative n power, so that's what I have right here, is equals the multiplicative inverse of its nth power. Well, I know that the multiplicative inverse of 5 is 1/5. And then of its nth power means that we just take this, right? It says to the negative n power. So the nth power would just be taking this number right here and leaving the negative. So it gives me 1 over 5 to the second power. Okay? So this is really, really kind of wild if you think about it. They're telling us we can just take this and write it in a different way. So what I'd like to do, kind of similar to what I did with the zero exponents, I want to show you why this is the case. So supposing I take this. Supposing we're going to take that 5 squared. One way I can get 5 to the negative 2 power. One way I can get 5 to the negative 2 power is, what happens if I have this problem right here? All right? I got 5 to the third, right, times 5 to the negative 5 power, right? You just add those together, get 5 to the negative 2 power. Another way of doing that would be as if I had 5 to the third over 5 to the 5th power. So I think we're going to concentrate on this example right here. We'll get rid of all this nonsense up here. So let's take a look at this example. 5 to the third over 5 to the 5th power. Well, we know from our law of exponents that we do 5 to the 3 minus 5, and then that will give me 5 to the negative 2. And like before, we talked about that, and I told you, well, you flip it and you make it 1 over 5 squared. But why is that? So let's expand this. You notice how with all these, I always go back to expanding everything, right? So write this as 5 times 5 times 5 because there's 3 of them. So there's your 3. This one, I'm going to write that out, except I'm going to write out 5 of them because that's how many factors we have. And then we're going to take and we're going to group them, like we've done a lot in the past, into single groups that we know are going to basically turn into 1 or cancel out. So you have 5 over 5, right? And that's going to cancel out and give me, basically 1. Another one cancels, and then another one cancels. And so that leaves me 1 over 5 times 5. Sorry, I should probably extend that fraction sign. And, you could write this as 1 over 25, or you could write it as 1 over 5 to the 2 to the 2nd power. Right? Well, if you look at this, it's 5 to the negative 2, and we do the rule, the trick they taught us, that's why this works. That's why this works, because essentially what you're doing is you're moving, it's switching positions and kind of going, where it's not. So I think once we do some examples with this will hopefully make a little more sense to you. But thank you for watching the video, and up next is examples of writing these.